Atif, any doubt? Abhinav, any doubt related to last class?
No doubt, sir.
Okay, we have defined a relationship between mean free path, average velocity, and relaxation time or time gap between two successive collisions. So we have to derive a relationship for this mean free path for whole volume. Suppose there is a gaseous particle having diameter d. So within the range of this diameter, it may collide with any other particle or gaseous particle. Suppose there will be another gaseous particle at this point. And so on. So this is diameter of this gaseous particle. So radius of this cylinder will also be d. So within this range of d, it may collide with any other particle. So let's say in time delta t, it may have moved up to this distance. So distance equals to average speed into time taken. Consider number of or number density of gaseous particle is small n, diameter of each particle is d. So within this range, it may collide with any neighboring particle. So we may define according to this number density equals to number of particle or gaseous particle divided by volume. This number of particle will also equals to number of collision. Number of collision in between them divided by volume. So number of particle or number of collision related to this formula will be number density multiplied by volume. Now this particular geometrical figure is like cylinder. So if you calculate volume of cylinder for this part, volume equals to pi r square into h. So r in this part we have d, and h is length of distance traveled by this gaseous particle to move from this point to this point. So it will be b average time delta t. Riba, is it clear?
Yes, sir.
So if you put in this volume part, you will get n pi d square average velocity into time taken. Now, just move this delta t to left side. N divided by delta t equals to n pi d square multiplied by average speed. This quantity is number of collision per unit time will also define you a rate of collision. So if you take a reciprocal of this part, delta t divided by n, it will call time between two successive collision, or which is simply equals to tau. Time gap in between two successive collision. So it equals to 1 by n pi d square multiplied by average speed. Abhinav, is it clear?
Yes, sir.
So according to the concept of mean free path, lambda equals to average speed multiplied by tau. So it will be equals to average speed multiplied by 1 over n pi d square. So this term and this term will cancel out. So you're left with lambda equals to 1 by n pi d square, where n is number density and d is diameter of gaseous particle. But this result is not the correct one according to experiment calculation result. There is some mistake in this expression. First write it down, then I'm defining you the correct version. Just write it down. Atif, done?
Yes, sir.
Okay. Now, what is the mistake in this particular expression? Let me define you. In derivation of this part, we have assumed that only this particle is moving and thus the whole other particle is at rest. So it makes collision with first particle, get deflected along this way, further along this, and so on. But in general, all particles must be in motion with respect to one another. So instead of assuming rest of whole particle to be at rest, it will be better to assume average of relative velocity in between them. Is it clear? Abhinav, any doubt?
No, sir.
Okay. So from this part, we can say in this result we assumed all other gaseous particle is at rest, and only one particle is moving in this entire part. But in general, there will be random motion between particles. So it will be better to take average of relative velocity of gaseous particle. Hence, the above expression transformed according to this as 1 by root 2 times n pi d square. Abhinav, is it clear why we have introduced root 2 in this expression? Riba? Okay. Abhinav, done?
Yes, sir.
Okay, so this is the entire part of this chapter, kinetic theory of gas. So just remember, in this entire part, you will be asked only 2 or 3 questions. First, pressure exerted by gas. Next, mean free path, calculation of degree of freedom, and to define absolute zero. Only these questions will be asked from this chapter. Okay?
Yes,
Atif,
sir.
any doubt? Okay, let's start new chapter. That is oscillation, or simply simple harmonic motion. So to define this oscillation, first, what do you mean by periodic motion? Suppose motion of a particular planet around sun. Suppose Earth takes 365.25 days to complete one revolution around the sun. So its time period is fixed around the sun. Similarly, it takes 24 hours to rotate on its own axis, which causes change in day and night. So its time period always also fixed to rotate on its axis. Similarly, we can say all different motion which may occur at fixed time gap, or for which, if time period is fixed, is called periodic motion. So you'll say the motion of a body having fixed time period is called periodic motion. Just like motion of planet around sun, motion of electron around nucleus, motion of bob in simple pendulum, and so on. Now, there is some difference in motion of simple pendulum and motion of electron or motion of planet. Let me define you. Suppose an electron is revolving around nucleus in fixed radius or around fixed orbit. So let's say this is nucleus. An electron initially is at this point. So on complete rotation along this way, it may reach to its initial position or starting point. So this is one way of periodic motion. In second part, I'm taking a bob attached to any string and is oscillating from one end to the other end. Along this path, like this. So in this, the starting point is called mean position. One end is one extreme and the other end is another extreme. So in this part, we can say bob is oscillating or moving to and fro about given fixed point, which is called mean position. So there is some speciality in this particular periodic motion, that it is going or moving along fixed path about given fixed point, that is called mean position, to and fro, and each half cycle it is repeating its own path. But in left hand side for electron, on complete rotation it may repeat its path again. So it is not defining about any given fixed point. We may take its initial position to be this part, to be this part, or any other part. But in case of simple pendulum, mean position will be always at this point. Is it clear? Abhinav, any doubt?
No, sir.
So from this part, we can say a periodic motion in which body moves to and fro or up and down about a given fixed point called mean position is called simple harmonic motion. A periodic motion in which body moves to and fro or up and down about a given fixed point called mean position. This special periodic motion is called simple harmonic motion, or simply SHM. Okay, just write it down. Atif, done?
Yes.
Any doubt?
No, sir, not.
Okay. Now let me define you this concept of simple harmonic motion. Give an example. So next is, first from this part we can say all SHMs are periodic, but all periodic are not SHM. Next, uniform circular motion as SHM. Consider particle is revolving along circular path at constant angular velocity. So let's say initially it will be at this point. Sometime it will be at this point, this, and may reach at this point while going along this path at some constant angular velocity. Similarly, on going along this path, at some time it will be at this point, this, so if you draw its projection, means shadow over x-axis. So its projection will be at this point. Further, it will be at this point, and further, it will be at this point. So if you define its motion, so first it will tend to go along this way to reach at this point. Further, move along this way to reach at this. So from this part, you will say the direction of these arrow is about this origin, to and fro, to and fro, to and fro. And this is defining nothing but motion of projection of particle about this circular motion along diametrical x-axis. Riba, is it clear?
Yes, sir.
Similarly, let me check this particular projection along y-axis. So if you draw projection along y-axis, first from this point, it may move along this way to reach at this point, then return back then further along this way. So if you calculate or if you define projection of these particles at different position along y-axis, it is defining movement along y-axis up and down, up and down, up and down about origin. So in first part, we can say motion of projection along x-axis. In second part, it is motion of projection along y-axis. So combinedly, we can say during uniform circular motion, the motion of projection of particle along any diametrical axis, that is about x-axis or y-axis, it will behave as SHM or simple harmonic motion. So from this part, we can conclude during uniform circular motion, the motion of projection of particle along any diametrical axis is called simple harmonic motion. Abhinav, any doubt?
No, sir.
Okay, just write it down. Abhinav, done?
1 minute, sir. Done, sir.
Rehab, you made a screenshot from the starting part. We have started. Done? Now, using this concept, let me define your equation of SHM. So next is equation of SHM. Consider particle is initially at this point. So if you join from origin to this point, let's say at t equals to 0, its inclination with horizontal would be phi. At some later time, it may reach to this point. At some time t, so during this, it may have traveled or displaced by omega t. So for this path, if we draw a vertical line and a horizontal line, this part will define your projection along x-axis. And in this part, it will define your projection along y-axis. So on calculating these rotational terms, you will be able to define different physical quantity related to the motion or projection of motion of this particular particle. So consider a particle of mass m is revolving along circular path of radius a at uniform angular velocity omega. Now, using this triangle, if we draw a vertical line and a horizontal line, total inclination from this point to this point will be theta. The radius of this particular circular path from this point to this point is A, and projection along x-axis x, and projection along y-axis is y. Total inclination theta will equals to omega t plus phi. Abhinav, any doubt?
No doubt, sir.
Okay. So if we take sine theta in this particular triangle, so sine theta equals to perpendicular divided by hypotenuse. So y will equals to a times sine theta, and theta we have omega t plus phi. So it will be an expression or equation of SHM along or projection along y-axis. Similarly, cos theta equals to base over hypotenuse. So x will equals to a times cos theta, and theta equals to omega t plus phi. So this will be your another equation to define SHM, or simply motion of projection along x-axis. So using these two equations, we may define SHM, and with respect to which we may calculate different term. So let me define you its physical interpretation of different term. X and y in this expression is called displacement of particle at any instant or at any time. A is called maximum displacement, or simply it is called amplitude. Next, omega is called angular velocity, which may define its time period as 2 pi divided by t, or frequency as 2 pi into f. So frequency is reciprocal of time period. In the last part, theta, it simply defines you phase at any instant. Phase or simply angle. So if you have to calculate initial phase, so at t is equals to 0, theta will equals to phi. So it is called initial phase, or the phase of this particular particle at t is equals to 0. Atif, any doubt related to these different terms?
No, sir.
Okay, just write it down. I'm giving example how to solve different term. Ihab, is it clear, or do you have any doubt?
Yes, sir.
Abhinav, done?
Yes, sir.
If y equals to 0.05 sine 4 pi t plus pi by 3. Find first maximum displacement, second time period, third frequency, fourth initial phase, and fifth displacement at one by each second. First, just compare this equation to the above equation, and on the basis of which you will be able to calculate these different terms. Like, compare this part, and this part. Try to solve. Just compare this equation with the above part. Y equals to A times sine omega times t plus phi. So on comparing, you will get A, that is also called amplitude or maximum displacement. Next, you will get omega, from which you'll be able to calculate time period and frequency. And next, you'll get this phi, that is called initial phase. Just compare these two equations and try to find Abhinav, you got any answer? Just see how to solve. Just compare this equation and this equation. Like in this part, we have coefficient of this sign as A, which is called amplitude or maximum displacement. So in this question, coefficient of sign we have 0.05. So on comparing, we can say A equals to 0.05. Abhinav, is it clear?
Yes.
Expression. In this part, we have 4 pi, and this part we have omega. So you will say omega equals to 4 pi. Is it clear?
Yes, sir.
And omega is equals to 2 pi by t in terms of time period, which is equals to 4 pi. So if you simplify it, t will be equals to 1 by 2 or just 0.5 second. Now, frequency will be just reciprocal of time period. So it will be equals to 2 hertz. Deba, is it clear? Try to find the value of phi on comparing. So phi will be equals to, like in this part, we have omega t plus phi, the constant part. Similarly, in this part, this is omega. So this must be equals to phi. So phi will equals to pi by 3. So next is phi or initial phase is pi by 3. So this is the second part. This is the third one and fourth one. Now in fifth part, we have to calculate displacement at this particular instant, 1 by 8 of a second. So y equals to 0.05 sine 4 pi t, t is 1 by 8 second, plus pi by 3. Just simplify it. 0.05 sine 4 pi divided by 8, it will be pi by 2 plus pi by 3. And you must have learned about sine 90 plus theta equals to cos theta. Similarly, in this part, we have sine pi by 2 plus theta. So it must be equals to cos theta. So 0.05 cos pi by 3. Cos pi by 3 is cos 60 degree, and cos 60 degree equals to 1 by 2. So it will be 0.05 divided by 2, or simply 0.025 meter. Abhinav, is it clear? Umar, any doubt? Good. Just write it down. Aisha, any doubt? Abhinav, done?
Yes, sir.
Okay. So this is how to calculate displacement and its various other parameters related to this equation. Next is superposition of two SHMs. It means adding of two SHMs. Suppose you have y1 equals to a times sine omega t, and y2 we have b times sine omega t plus some phase difference phi. So when you add these two equations, what would be the resultant part of this sum? So on adding, you will get y equals to capital A times sine omega t plus some delta. It means the resultant of two SHM will also an SHM. Only there will be change in its amplitude and its phase. So how to calculate amplitude and phase? Where A equals to root under A squared B squared plus 2AB cos phi, and delta equals to B times sine phi divided by A plus B times cos phi, which is similar what we have derived for resultant of two vector in chapter 4. Reba, is it clear?
Yeah.
We will prove this particular statement in next chapter, that is in VU. Okay. So up to this part, just remember this particular expression. So you will say superposition or adding of any two SHM will also be an SHM. Only there will be change in its amplitude and phase. Its time period will remain same. So superposition of two SHM will be also an SHM only amplitude and phase changes, time period and frequency remains same. Just write it down, then I'm giving you some problem related to this part. Aisha, any doubt? Abhinav, done?
Yes, sir.
Okay. Now, related to this concept, you will be asked if y1 equals to 3 times sine omega t and y2 equals to 4 times cos omega t. Find amplitude of the resultant of y1 and y2. Let me define you how to calculate. First, y equals to y1 plus y2. So we have 3 times sine omega t plus 4 times cos omega t. In above part, we have both function to be in same term, that is in sine and sine. Similarly, for this part, we have to convert this cos in terms of sine first. So how to convert? Using relation cos theta equals to sine theta plus pi by 2. You may write like this. So it will be equals to 3 times sine omega t plus 4 times sine omega t plus pi by 2. Iba, is it clear? Okay. So from this part, this expression, and this expression, it will behave as A, it will behave as B, and this is phi. So according to the formula, amplitude equals to root under A square, B square, and 2AB cos phi. Just put all the values and simplify it. You'll get your amplitude for this resultant. Abhinav, any doubt?
No, sir.
Try to find. Abhinav, you got any answer?
1 minute, sir.
Okay. Just put the values of A, B, and phi and simplify it. Riba, just send your answer. Let me solve. A, we have 3. So 3 squared. B, we have 4. 4 squared. 2 times A multiplied by B, and cos of pi by 2. Cos pi by 2 is cos 90 degree, and cos 90 is 0. Root under. So this entire term will become 0. So you're left with 3 squared 9, 4 squared 16, root under. So it will be just 25 root under, or it will be just 5 meters. Abhinav, is it clear?
Yes, sir.
So from where you have got this so much large result?
Sir, I got confused in that cos pi 2 part.
Okay. Riba, is it clear?
Yes, sir.
Okay. Just write it down. Now, related to this part, you'll be asked to define velocity and acceleration. So next is velocity and acceleration in SHM. As we have displacement equals to A times sine omega t. I'm just considering initial phase to be 0. In this part, we have 2 different functions. First is sine, this part, and second one is angle, this part. So we can say this is composition of any 2 different function. So if you have to differentiate, we may assume function of function. So differentiating with respect to time, dy over dt, A being constant, keep it outside, differentiation of sine will be cos omega times t, and further differentiation of omega d, in which omega being constant, keep it outside, and differentiation of t will be just 1. According to the relation, if we have x to the power n, so differentiation will be nx to the power n minus 1. Similarly, in this part, we have t raised to 1. So on differentiation, it will be 1t to the power 1 minus 1. That will be just 1. Riba, is it clear?
Yes, sir.
So this quantity dy over dt simply defines your velocity equals to omega times of a cos omega into t. Now we have to move on this, transform this particular relation in terms of sine theta. So how to calculate? You may write omega times a sine omega t plus pi by 2 according to the relation of complementary part. So from this part, you will be asked to define phase difference between displacement and velocity. So how to calculate phase difference? Simply difference the angle of these two different functions. Just in this part, for displacement, we have omega t. But in case of velocity, we have omega t plus pi by 2 if both having same function. So from this part, we can say phase difference between these two terms is pi by 2. Riba, is it clear?
Yes, sir.
Phase difference between displacement and velocity is pi by 2. Next, you will be asked to define this velocity in terms of displacement. So how to derive it? Let me define you. Now, velocity is equals to omega times of a cos of omega into t. There is formula and trigonometric identity sine square theta plus cos square theta equals to 1. So we may write cos theta equals to root under 1 minus sine square theta by bringing the sine square theta to right side and taking square root over it. So we may write cos theta equals to this expression. Similarly, for this part, we have cos omega t. So we may write root under 1 minus sine square omega t. Now move this a inside of this root. So it will become omega root under a square a times sine omega t whole square. So this quantity a times sine omega t is nothing but y. So it will be equals to omega root under a square minus y square equals to velocity. So this is another expression of velocity in terms of displacement. Abhinav, any doubt? So from this part, we may define two different terms. First, for mean position, where displacement will be minimum. So if you put this y in this expression, you will get velocity maximum as omega times of a. At extreme position, y is maximum, so velocity will be minimum, that will be 0. So you'll be asked to find maximum velocity. It means V max equals to omega times A. Riba, any doubt?
No.
Okay, just write it down. Aisha, any doubt?
No, sir.
Abhinav, done?
Yes, sir.
Now, for this part, you'll be asked if y equals to 5 sine 10 pi t. Find first displacement at just 1 minute. Simply pi into t, then find displacement at 1/4 second, velocity at 1/4 second, and third, maximum velocity. First, put the value of t in the above expression. You will get displacement. Then, using the above expression, velocity equals to omega times root under a square minus y squared. You have omega as pi, a, and y. Put this value and try to find. And similarly, Vmax, according to the above expression, is omega times a. Try to simplify these three different terms. In first part, if we put y equals to 5 sine just pi into t, which is 1/4, so it will become pi/4. And sine of pi/4 is sine 45 degree, which is equals to 1/√2. So it will be 5 into 1/√2. So if you simplify it, you will get 3.5 meter. Now, according to this equation, we have omega is equals to pi, a is equals to 5, and y we have calculated as 3.5. So just put these values in this expression and simplify it, you'll get your velocity. Riba, any doubt?
No, sir.
Yeah. So velocity equals to omega, that is pi root under a, which is 5. On squaring, it will be 25 minus 3.5 on squaring, it will be 12.25. So pi 25 minus 12.25, it will be 12.75. Okay, now take a square root of it.
Sir,
Yes,
how did you get 1 by root 2 for the previous one?
sine pi by 4, that is sine of 45 degree. Sine 45 is 1 by root 2. Okay.
Okay.
So it will be around 3.57 into pi. You may put pi to be 3.14 and multiply it. Abhinav, any doubt?
No doubt, sir.
So in last part, omega is just pi and amplitude we have 5. So it will be 5 pi meter per second. Meter per second. Umar, any doubt? Good. Abhinav, done?
Yes, sir.
Any doubt in this whole
No doubt.
calculation?
Sir,
Yes.
how is sine pi by 445 degrees?
In terms of angle, pi is called 180 degree. Okay.
Okay, sir.
Divide by 4, so it will be just 45 degree.
Yes, sir.
In second chapter, units and dimension, I define you how to calculate angle in radian measurement and in degree measurement. So 180 degree in terms of radian measurement, it will be pi. Next is how to calculate acceleration in this SHM. Now, we have displacement as a times sine omega t. So on differentiating it, you will get velocity as omega times of a cos omega t. Now again in this expression, we have this as constant outside of this particular function. Cos is variable function or trigonometric function related by omega t algebraic function. So if you have to differentiate it to find acceleration, so differentiating with respect to time, dv over dt equals to omega times a being common or constant, keep it outside. Differentiation of cos is minus of sine, omega into t And further differentiation of omega t, in which omega being constant, keep it outside, and differentiation of t will be 1. So this expression dv over dt will be acceleration minus of omega square e sine omega into t. So this will be your acceleration. Now, if you transform this particular expression as sine of theta with negative sign, may be written as sine of theta plus pi. I have done these things in mathematical physics and the beginning of motion in straight line, or at the end of dimensional analysis. I define you these different things in trigonometric section. So you may write this part as minus of omega square a sine omega t plus pi equals to. So if you relate with above term to find phase difference, this is for velocity and this is for acceleration. So for displacement, we have just omega t, this part, but for velocity, we have omega t plus pi by 2. And now for acceleration, we have omega t plus pi, all having same function, sine, sine, and sine. So as a result, or conclusion, we can write velocity, displacement, and acceleration each differ by phase difference pi by 2 in between them, and in between velocity, displacement, acceleration, phase difference will be pi. So this is relation between phase for displacement, velocity, and acceleration. Riba, any doubt?
Sir.
Abhinav, any doubt related to this different term?
Sir.
You'll have done?
Done, sir.
Now, next question will be asked related to this part. What would be the path for relation between velocity and acceleration, velocity and displacement, and acceleration and displacement? So let me define you how to. According to velocity and displacement, it was omega times a squared y squared. So if you square this particular term, both sides, you will get v square equals to omega square a square minus omega square y square. On solving, you will get v square divided by omega times a square plus y square divided by a square equals to 1, which is nothing but elliptical in shape, or simply equation of ellipse. So if you will be asked to define path of relationship between displacement and velocity, it will be elliptical in nature. Similarly, for acceleration and displacement, as a we have omega squared a times sine omega t. This is nothing but y, so it will be minus of omega square y. So graph related to this part will be linear, or path related to this part will be linear. Abhinav, is it clear?
Yes, sir.
Now, the next thing we can define related to this part, you will be asked what would be the minimum condition for an equation to be SHM. So you will say from this part, acceleration equals to minus of omega square y, and this part omega square is constant. So acceleration is directly proportional to displacement with some negative sign. This is condition of SHM. So for any equation, just differentiate it twice to get acceleration. And if your relationship is something like this, then it will be SHM. Otherwise, it will not be SHM. Reba, is it clear?
Yes, sir.
Now, you will be asked to derive general differential equation of SHM. First, write it down, then I'm defining the rest part. You all have written?
Yes, sir.
Okay. Now you'll be asked to derive general differential equation of SHM. So how to define as displacement equals to A times sine omega t. So on differentiating dy over dt, it was omega times A cos omega t, the expression of velocity. If you again differentiate it, that is dv over dt. So you may write as d over dt, and for velocity, dy over dt, it will be equals to minus of omega squared A times sine omega t. This particular part is simply called second derivative of displacement with respect to time. So it is also called acceleration, is equals to minus of omega squared, and this part is nothing but displacement. Now move this expression to left side. So d2y over dt squared plus omega square y equals to 0. This is called general differential equation of SHM. So in your exam, you will be asked to derive this general differential equation of SHM. Is it clear? Atif, any doubt?
No, sir.
Okay, just write it down. You have done up to this part?
Yes, sir.
Any doubt? Aisha? Okay, so let's stop here for today. This is the entire part of first part of this particular chapter, SHM, in which I had defined you displacement, velocity, and acceleration, and its various other factors. So just revise this and try to do a problem related to this part. In next class, I will define you energy on SHM, and then define your calculation of time period. Okay.
Yes.
Okay, then we'll continue next class.
Bye, sir. Thank you.
Thank you.
Thank you, sir.
Thank you.